Hey guys, so 7-3 today, proving triangles similar. So now we're going to move on from just polygons in general, and we're going to actually be using the angle-angle similarity postulate, the side-angle-side similarity, and the side-side-side similarity theorem. So remember that little wavy line? That one simply means they are similar, okay? So they have a common ratio. All right, so let's just warm up a little bit, write the converse of each theorem. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So converse, if the parallelogram is a rhombus, then the diagonals of a parallelogram are perpendicular. Okay. What about if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment? Well, if a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector of a segment. Okay, just a little warm up here. See if we can refresh the brain a little bit. So let's warm up and do this. Okay, pause, see if you can answer this. Okay, so we're back. So are they similar? The answer is yes. How do you know? Well, we know that angle A is congruent to angle D, angle B is congruent to angle E, and angle C, do some quick math, you'll find is congruent to angle F. 70 degrees. So if all three angles are congruent on a triangle, then they are similar. And you should have found that if you measured the side lengths of each one, that should also be similar to each other as well. They have a common ratio. Ooh, excuse me. So that leads us to our first theorem or postulate. Okay, the angle-angle similarity, right? If two angles of one triangle are congruent to two angles of another triangle, then that triangle, those triangles are similar, right? If S is equal to M and R is equal to L, then that triangle is similar to that triangle. So if we know two angles on a triangle and two angles on another triangle, we can prove whether or not they are similar. Okay, you might be asking, well, why not just use that third angle? Well, if the third angle, right, it's just supplementary to the other two, so it's always going to be the same. So that's why you'll really only need two of the angles to find that. So down here, let's apply the angle-angle similarity postulate. Angle or triangle RST and triangle NOP, are they similar? Well, S is equal to O, they're both 90, and N is equal to R, so therefore T would be equal to P, so yes, right, angle-angle postulate says so. Our second one, okay, G is 40, T is 80. Okay, well, G and D are both 40, so that could work. We need to find that other angle though. What's angle H? Well, 40 plus 80 is 120, minus 180 is 60. And this one would be 105. Are those two triangles similar? No. They have different angles. Okay. There's also two other postulates or theorems that we know. Okay. Another is a side angle side. Now that shouldn't be new, right? If an angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. Okay, like the diagram there. If AB is equal to QR, or excuse me, if AB is similar to QR and AC is similar to QS, and A is equal to Q, then those triangles are similar. Remember, not equal, similar. They have the same ratio. We can also use the side-side-side similarity, right? If all three sides are similar to another triangle, they are similar triangles, okay? Which would also mean the angles are equal. All right, so let's apply that to a couple problems. Are the triangles similar? Yes or no? If so, write a similarity statement. So first one, we have 24 and 12, 10 and 5, 13 and 26. Yes, they are. Why? Well, let's write out that similarity statement. So I could say triangle is similar triangle SKR. Why? Side-side-side similarity. That's why. What about letter B? Okay, we have triangle TUS and triangle TVR. Well, is 10, excuse me, not 10, 10 and 14 is 10 plus 4, and then 12 over 16.8. Okay, you should find that they are both the same ratio. they convert to the same ratio. So these are also, yes. Triangle TVR is similar to triangle TUS, and that is because of side angle side. Done. Let's finish out a proof here, proving they're similar. So we know FG is equal to GH. We know JK is equal to KL. We also know angle F is congruent to angle J. Prove that those two triangles are similar. So we already have the given information. Now, how do we know triangle FGH and JKL are both isosceles? Well, that's a definition of an isosceles triangle. Bad triangle. Number 3, angle F is equal to angle H, angle J is equal to angle L. Well, that is because base angles of isosceles triangles are congruent. Number 4, angle F is equal to angle J. That's given. Number 5, angle H is equal to angle J. That is the transitive property. As is number 6, also the transitive property. And number 7, how can we prove that? Well, we just found that two angles are equal in the same triangle, so angle-angle similarity. Done. Okay, our last problem, problem number 4. This is a fun one. Benjamin places a mirror 40 feet from the base of an oak tree. I'm going to draw a picture here. There's my oak tree. A mirror 40 feet from it. When he stands at a distance of 5 feet from the mirror, okay. He can see the top of the tree in the reflection. Okay, if Benjamin is 5 feet 8 inches tall, what is the height of the oak tree? All right, so I don't know about you, but I kind of see a triangle being developed here. Okay, we see 5 feet up 8 inches. Okay, I'm going to convert. Oh my goodness, can't talk. I'm going to convert this to inches so it's all the same unit. So rather than 5 feet, I'm going to make it 16 inches. Instead of 5 feet 8 inches, that'd be 68 inches. What does that equal to? What's our other ratio? Well, when it was 5 feet, it was 5 feet 8 inches. When it's 40 feet or 480 inches, and we don't know the height of the oak tree. So we have a ratio set up here. Let's cross multiply and divide. So 68 times 480. So far, so good. We divide by 60 and we find that X is equal to 544 inches. Which can be your answer. If you want to convert that to feet, that's great too. It'd be 45 feet, 4 inches. And there's our answers. Okay, so we can see how we can use these proportions and set them up. All right, your homework, page 50. What do I do? Uh-oh. It's not responding. Well, your homework is on page 15 and 16. It is all of the problems. You don't have to worry about skipping any of them. If you guys do have questions, please let me know. Otherwise, that is your homework. Okay? Have a wonderful rest of your day, kiddos. Page 15, 16. See ya.